Today we're going to start talking about your new unit called probability. Now the probability unit isn't very long, but I'm going to make sure that every day I'm going to have a video that's going to be posted that's going to explain to you topic 1, topic 2, and so on. I'm going to do one video a day about probability. It's going to be the notes section of it, and then I'm going to explain a little bit about what the assignment's going to be based upon the chapter or notes. It's very similar to the structure for how we did vehicle finance, where I would give you the notes, as I would call them, and then we would go through some of the example questions, which were very similar to what you would find in the actual practice questions, so the assignment sheet. So let's talk about probability. Probability, topic 1. What is probability? Now, I'm going to read a little bit from your notes here, and I know I gave everybody a collection of these before you left for your extended time away from the school for Christmas. If you don't happen to have this set of notes, let me know and I can possibly email them to you. I'm hoping you do though, because I'm positive I gave everybody a copy of these. So topic 1, what is probability? Well, in this topic 1, our objective, or two of the objectives will be to represent the probability of an event on a probability scale. Objective number 2, express probability as a fraction, a ratio, a decimal, percent, or a statement, a probability statement. And objective 3 is to apply probability to real life problems. So, probability, in the short form of the definition, is the chance or likelihood that a particular event will occur. And they give you the example of an event that can occur, that is when you flip a coin, like a penny. You have heads or tails. When you flip a coin, it is equally likely to land heads or tails. We say the probability of the coin landing heads is 1 out of 2. 1 out of 2 can be put into a form of a ratio. So, a ratio looks like this: 1 out of 2. The colon in the middle is kind of like, means out of. We could also write it as 1 over 2. Or we could also write it as we have a 50% chance of that penny landing on heads, or 50% chance of landing on tails. In some cases, the coin toss, and this is straight from your notes, is easy to predict the probability of an outcome, and because of that, this type of probability is called theoretical probability, because it's easy to predict. You have two choices. It's either going to be heads or tails. Flipping to your next page. Probability is the chance of an event occurring. So, an event is a possible outcome. So, an event is a possible outcome in a situation where more than one outcome is possible. For example, if you flip a coin, a possible event is the coin landing heads. The probability of an event must be greater than or equal to 0 and less than or equal to 1. The following formula in your notes can help you find the probability of an event. Now, I'm going to probably use a different color marker because my black marker is dying. So what I'm going to do is use a brown one so you can possibly see it here. So I'm going to use a short form, PE. Probability of an event equals the number of ways the event can occur, divided by the total number of possible outcomes. I don't want to say divided by, over the total number of possible outcomes. I recommend that you keep this close because you're probably going to see this in a few questions coming up. So the probability of an event is the number of ways the event can occur over the total number of possible outcomes. There's a typo in your notes. It should say event, not event. So then we have this thing called a probability scale. Now, probability scale is the idea that you have on the left side, it's impossible. Then you have, in the middle of it, an equal chance that it could happen. And then you have a certainty that yes, it can and it will occur. But then underneath you're going to have on your chart, if you look at it here, you're going to see that there's going to be in between impossible and even chance, it's sort of pretty much not likely that's going to happen. Then from equal chance to certainty, it's pretty much likely that it could. Not likely, and pretty much, well, likely. So a probability scale allows you to rate events based on their probabilities of occurring. So the number of ways an event can occur is always less than or equal to the total number of possible outcomes. Let's take a look at, I'm not going to get too much into the formula, I'd rather get into the probability scale. So let's take a look at example 1 on the probability scale. The sun will rise in the east next Sunday. Represent this event on the probability scale that's on your assignment, your practice question there, your example question 1. Let's use the probability scale of where it says 0 impossible to A certain. Label where you think it should go with a dot and letter A. On the probability scale, I don't know if you can see mine, but I have impossible that it won't occur, equal chance that it might happen, and a certainty of yes, it will occur. Now remember this. The sun will rise in the east next Sunday. The sun rises in the east and sets in the west. It always does. It will never change. And if that changes, there's something going on globally with the world that we need to be worried about. So in this one here, it's a certainty that the sun will always rise in the east, because that's where it always does. Rises in the east, sets in the west. So you put a dot right at the certainty spot there and say, yes, it's going to happen. It's the likelihood that it will occur. Example 2, the next baby born in your local hospital would be a boy. Represent this event on a probability scale. Well, here's the thing. Babies are born every day. And then there's going to be a baby born. It's either going to be a boy or a girl. We don't know for sure what the statistics would be when it comes to what the percentage of babies born in, say, the PA would be, or FIMPA being boy or girl. But here's what we do to be safe. We would say there's an equal chance that the baby that's going to be born in the next hour in the PA will be a boy, or 50% chance it will be a girl. So we put it right in the middle, that there's an equal chance on the probability scale. Example 3. Somewhere in Manitoba, the temperature will reach at least 4 degrees Celsius once next year during the month of January. Represent this event on a probability scale. Now here's the thing. It's not impossible that, we'll say 2022 in January, that we might get a +4 day. It's not impossible. It's knowing that the temperature in wintertime around January is usually -10 or colder in somewhere in Manitoba. It's still not going to make it an impossibility that we might get a +4 temperature somewhere. So for that one there, I would say it's not likely, but it's not impossible. It's somewhere in the middle between impossible and equal. I would put a dot right there. So that's how we basically use the probability scale. Now, the probability scale, there is a formula where it says 0 is greater or less than or equal to the event, which is greater or less, or which is less than or equal to 1. The formula is 0 is less than or equal to the probability of the event, or less than or equal to 1. Now, quite honestly, I'm not getting you to worry about that formula. Just understand how the probability scale will work. Knowing that there's an impossible opportunity for it to occur, there's an equal opportunity, and then there's a certainty for it to occur. There is a formula related to example 1 using that. If the probability of it snowing on December 22nd is 50% chance, or 1 out of 2, what's the probability of it not snowing? Well, the probability of it not snowing is we use the formula that P is snowing plus P not snowing equals 1. Therefore, the probability of it not snowing on December 22nd is 1 out of 2, or 50%. Pretty much, I'm going to tell you right away, don't worry about using that formula, just the probability scale. Now, expressing probability can be as a ratio. And I showed you that earlier today. 1 out of 2. As a fraction, 1 over 2. As a decimal. As a decimal, it could be 0.5, which is as a statement. It can be written out as 1 out of 2. And then there's some examples there. There are 13 spades in a deck of 52 cards. There are 13 spades in a deck of 52 cards. As a fraction, that can be 13 spades over a total of 52 cards. As a decimal, you take 13 and you divide it by 52. That tells you that there's 0.25 of those cards would be the spades. Now, as a percent, you take that 0.25 and you times that to 100. 25% of those cards in that deck of 52 cards will be spades. Now, as a word form or statement, you can write like this. There's 2 ways you can write it. 1 out of 4 cards will equal a spade. Or you can say like this. 25% of the cards are spade. So those are the 4 ways to write a probability, to express a probability. Have example number 2. You have a city is interested in knowing how many of its roads and sidewalks need to be repaired. A city engineer randomly inspects 38 city roads and finds 4 that need to be repaired. He also finds that 6 out of the 45 city sidewalks he inspects need to be repaired. So example 2a says, what is the probability a city road has to be repaired? Express this probability as a fraction, a decimal, and a percent. Well, he inspected 38 city roads and 4 that needed to be repaired. So as a fraction, the 4 that need to be repaired would be over the 38 that the inspector did look at. Now, as a decimal, you take 4 and divide by 38, you should get 0.105. And as a percent, well, 10, it's going to be 10.5%, but 0.105 times 100 would give you 10.5%. So 10.5% of the roads that he inspected need to be repaired. Now, what is the probability of a city sidewalk? This is part 2B. So a city sidewalk as a probability, fraction, and decimal percent. Well, he inspected a total of 45 sidewalks. 6 out of 45 need to be repaired. As a decimal, 6 divided by 45 will give you 0.133, and then there's going to be a line on top of there. That means that that decimal keeps repeating. So we're only going to take it to about 1, 2, 3, 4 decimal places. As a percentage, 0.1333 times 100 will give you a percentage of 13.3% of your sidewalks that he inspected have to be fixed. That is example 2 expressing probability. Now example 3 is going to involve a sports event, a soccer game or soccer season. This is number 3 example. During the regular playing season, 10 out of 84 games in a particular soccer league go into overtime. What is the probability that a particular game will go into overtime? Express the probability as a fraction, a decimal, and a percent. Well, as a probability, 10 out of 84 games will go into overtime. As a fraction, that's 10 over 84. As a decimal, well, that's 10 divided by 84. That's going to give you 0.1190. As a percent, that's going to give you 11.90%. Now this is where things are going to be a little different here for 3B. It asks you, based upon the above probability, how many of the league's 16 playoff games will go into overtime? Well, you have 10 out of 84 that will, but we're going to say how many that of the 16 playoff games will go into overtime. Well, we have 16 playoff games, but we are asking how many of these games out of the 16 might be overtime games. We don't know. So what I've created for you here is basically some math that we can figure out. Now what we're going to do is we're going to go and say, okay, this guy, 10 times 16, actually let's do this first. 84 times x. Well, that'll give us 84x. We're simplifying the equation. 10 times 16 will give you 160. Now we need to get the x by itself. It becomes like an algebra question. How do we get the x by itself? Well, if it's multiplying by 84 here, we're going to divide by 84 on both sides. What it does is it eliminates the 84 here, leaving us with x equals. Now x is going to equal whatever 160 divided by 84 would give us. In this case, it will equal to be 1.9, but you can't play 1.9 games. You can really pretty much just round it up to, well, it's going to be 2 possible games. 2 possible playoff games. That means that 2 possible playoff games out of 16 playoff games might go into overtime. Now, what the great thing about doing a video is that you can stop as you listen and as you watch the video to see the steps. I recommend doing that because this is a bit of a longer one. This might be about a 10-minute video. I want to talk a little bit about what your assignment is. The first set of questions in your topic 1, lesson 1 practice questions are going to involve a probability scale that we did earlier in the video. Then it's going to have you rewrite the following statements using the words, without using the words chance, probability, or likelihood. Think of the math that you see in the statement. Now I'm not going to get too much in that. That might be the toughest part of the assignment, is questions 2A, B, and C. Question 3, the probability scale thing. I think I want you to look at that one there and think to yourself, okay, if A is 0 and E is 100%, what would you suggest that B, C, and D would be mathematically? Now, number 4 is how you're going to express the 1 in 12 as a decimal and a percent and a fraction. It's already given to you as a ratio, 1 in 12. Question 5, probability of an airplane crashing on a flight is 0.005. Would you consider this an acceptable level of probability? Think about how you would talk about that decimal as a way of saying yes, it could occur, or no, it can occur. But think about how you would describe that to me. How would you show that 0.005 as a probability in 3 ways? Consider the following statement for question 6. It's 99% effective. It's effective 99% of the time. Explain your thoughts on this statement using the probability scale, possibly. And what does it mean when something is 99% effective? 99 out of what? Number 7 is very similar to the idea of the sidewalk and the road question in your example sheet we did. So I'm not going to say too much about that. Complete the following chart for question 8. Look carefully at the chart and think how you could write those in the other ways with the information they gave you. And number 9 is very similar to number 8, just adding, I do believe, fraction. Nope, fraction, decimal, percent, word. It's just the same way as number 8, just a little bit slightly different for how they organized it. That is your assignment list right there. Did I forget the last page? No, that's a probability unit, topic 1, lesson 1, practice questions, me explaining a little bit about what I'm expecting, and that's your assignment for this activity.